All right, Algebra 2 friends, we are going to look a little bit as an overview of Topic 3, Section 1, and this is just about graphing. Please watch Miss Dean's videos. Those are the videos below this one that give you a little bit more information in depth about the different types of polynomials. And so we're looking at graphing polynomial functions. So we know a quadratic looks like this. We know a quadratic is an x squared. Well, the thing is that anything with an even exponent will look like that. Anything. Anything with a negative x squared looks like this, right? It reflects. Again, that's an even exponent. So anything with an even exponent is going to look like that. It doesn't matter if it's an x to the fourth. It'll just do a little joggy thing down here or this way. But all of our even functions look like that. They look like parabolas in some way, shape, or form. They just might have some extra bits here. Contrary, a cubic, let's try that again. A cubic, an x to the third function, is going to go like this. And a negative cubic is going to reflect and go like this. So, yeah, and it doesn't matter if it's an x to the third or an x to the fifth or an x to the seventh. This is any odd exponent. So if I were doing an x to the fifth or seventh or 23rd, as long as it's odd, it's still going to go like this, but you'll get some extra little bits there. And then if I did a negative of that, so if it had the coefficient of -1, -1 x to the 27th, it's going to just go this way. And then down here, you're going to have little joggy things, okay? So when we're talking about end behavior, we're asking what happens at the ends of the graph. Again, if we're even and we're positive, so we have a positive x to the even power, then our end behavior is going to be positive, positive. So as x, remember this is my x-axis, right? So as x goes to negative infinity is this way, what happens to y? Y goes, so again, here's my y values. Y goes to positive infinity. And that happens again over here. Even as x goes to positive infinity, then y goes also to positive infinity. So that's the terminology that they're going to talk about. So if it's even, it's going to be like that. So as x, let's go back and do a different color there. As x tends to negative infinity, y tends to positive infinity. As x tends to positive infinity, y tends to positive infinity. Now when we start talking about our odd functions, so x to an odd power, positive, then we go like this. So things change a little bit. Here's my x and y axis. So this time, here's negative infinity this way. As x goes to negative infinity, well, what happens to y? Here's y. I go down, which is to negative infinity. And then as x goes to positive infinity, remember this is my x-axis here, what happens to y? Y goes to positive infinity. So if I'm talking about that, I would say as x tends to negative infinity, y tends to negative infinity. As x tends to positive infinity, y tends to positive infinity. So these match here, these match here. Okay? So when you're asked questions like that on the homework, that's kind of the terminology that they're looking for. Okay, I know you all love key features, and so this is one more problem about key features. But now we're talking about our exponents being something other than x to the second or x to the first. We're talking about x to the fourth. So really this is the same idea as before. We can graph all of this and it'll tell us kind of what we need to know just by doing our graphs. So things that they're going to ask are those tendencies. So what's happening to the graph? They might ask you what it might look like. They might ask you to use the table. If you want to use a table and you're looking for where is the table, right here under this guy, you can click on him and it'll give you a table option, and then it'll give you the table. So let me show you what that looks like. Okay, so here's the same thing, but now I have the table up. When I pull the table up, it gives me some whole numbers. So if I'm asked for the x-intercept and I find that it looks like this kind of wonky thing here, the table might be helpful for being able to figure out turning points and things like that rather than having to look at the graph. So you may want the table, you may not. I personally did the questions on your homework and did not use the table at all. I could tell everything that I needed to from just looking at the graph. So when it talks about turning points, it's talking about what's happening at the max or the min of each function. And this function has more than one max and more than one minimum because it has several turning points. So we're thinking about that roller coaster that we've talked about before. We're going up the roller coaster right here. When do we stop going up the roller coaster and we start going down? That would be our first turning point. So this would be a turning point right there. And that turning point looks like it happens between, this is -2 right here, and this is -1. So that looks like it happens between -2 and -1. The next turning point happens, I'm going down my roller coaster, and then I start to go back up my roller coaster. And so that looks like that happens between about -1 and about +1. And then it looks like I have one more turning point, so I'm going up my roller coaster and shoop, now I'm going back down the roller coaster. So that looks like that happens between +1 and +2. So when it's asking for the turning points, it's asking for where am I turning on my graph. And that should be about everything that they ask you to do on the graph that you've never seen before. It's going to ask you to match the graph. Make sure that when you're matching the graph, you are looking at not just the shape, but also where it's crossing the x-axis. It's also going to ask you for the x-intercepts. That's not new. That's not different. We know that the x-intercepts, sorry, I got to get the right color that's going to actually show up here. There we go. So this is my x-intercept and this is my x-intercept. Now the one on the homework comes out as a whole number, so that's a lot nicer. And then when it asks for what is the y-intercept, well, our y-intercept is this guy right here, where it crosses. This is my y-axis and this is my x-axis. So it's where it's crossing my x-axis and my y-axis, just like everything else we've done before. I will try to give a little recap video on each of the sections from now on. That might help a little bit while I'm out. I cannot promise anything. I take Thursdays where are days that I can work and someone else is able to hang with Aaliyah. So I'll do the best that I can. Please keep sending me questions if you have them, and I hope this was helpful.